Number one, Clay rolls a six-sided die 16 times. The scores obtained are shown in the following frequency table. This table, and it is given that the mean score is 3. Find the value of P and the value of Q. Okay. So according to this table information that uh, P plus Q plus 4, okay, this is 16, plus 2 plus 0 plus 3 equals 16. So P plus Q equals 16 minus 3 minus 2 minus 4, and it is 7. So the first equation is P plus Q equals 7. Next. This is the first equation. The second equation, that 1 times P equals P. We're now writing this base, plus 2 times Q is 2Q. 3 times 4 is 12. 4 times 2, 8. 0. 6 times 3, 18. And it is equals P plus 2Q plus how much is 12? 38. Okay, plus 38 over this one over 16 equals, according to this information, that mean score is 3. P plus 2Q plus 38, 48. P plus 2Q equals 48 minus 38 equals 10. This is the second equation. We will determine P and Q through this equation and this equation. P plus Q equals 7. P plus 2Q equals 10. Minus Q equals minus 3. So Q equals 3. So this is 3. Now we're going to find P. P plus 7. P plus Q, sorry, equals 7. P plus 3 equals 7. It means P equals 4. So this is P equals 4. Okay. So P equals 4 and Q equals 3. Next. Each of credit scores is multiplied by 10 in order to determine the final score for a game she is playing. Write down the mean final score. Right. To find the mean final score, we have to calculate 1 times 4 times 10 according to this information multiplied by 10. It is 40. 2 times 3 times 10, 60. 3 times 4 times 10, 120. 4 times 2 times 10, 80. 0, 0, sorry, not none. 6 times 3 times 10, 180. So if we calculate it, wait, I'm going to calculate with my calculator, is 100 plus 120, 220 plus 80 plus 180 equals 480. Okay. So we're going to find the mean final score, B. Mean final score 480 over 16 over 16, and it equals 30. Number 2, it is given that log 10a equals 1 over 3, where a greater than 0. Find the value of log 10, 1 over a, and log 1000 a. Okay. A log 10, 1 over a, we can write things like this: log 10 a power minus 1, and it is minus log 10 a. According to the information, this one, that log 10a equals 1 over 3, so it is minus 1/3. Now this one, B, I'm going to use in this space, B, log 1000 a, we can writing like this: log log 10a, log 10a over log 10 1000, and it becomes log 10 a. It is 1/3, actually it's 1. I will convert this, becomes 10 cube, so becomes log 10a over 3 log 10 10. It is 1 over 3 over 3 times 1. 1/3 times 1/3. It is 1 over 9. That's the solutions of B. 3. Points A and B lie on the circumference of a circle of radius r centimeters with center at O. The center OAB is shown on the following diagram. This diagram. The angle AOB is denoted as theta. Okay, this theta, and is measured in radians. Okay. The perimeter of the sector is 10 centimeters, and the area of the sector is 6.25 centimeters square. So the perimeter AO plus OB plus AB is 10 centimeters, and this area is 625 centimeters squared. Show that 4r squared minus 20r plus 25 equals 0. Okay. The circumference Circumference of a circle is 2 pi r if in radians. And AB, to find AB, AB is theta, this angle, theta over, supposed to be 360, but if in radians, we have to writing 2 pi. So theta over 2 pi times circumference, 2 pi r. So it is theta r. Next, AO plus OB plus AB equals AO is r centimeter, is r, OB is r, so it means plus AB, it means 2r 2r plus pi r. Okay, but wait, I'm going to better if I write like this. Maybe some of you will confuse 2r, okay? AO plus OB, right? So it means 2r, AO plus OB, 2r plus AB is this one, theta r. According to this information that this is 10 centimeters, okay? This is the first equation. That's based on circumference. Now, based on area. The circle area formula is pi r squared. And sector AOB is theta over 2 pi 360 times pi r squared divided, and it is theta r squared over 2 over half theta r squared. And according to this information that this is 6.25. So this is the second equation. All right, from the first equation and second equation, we can determine R. Okay, now we can determine this equation. What we have to find R. So 2R plus theta R equals 10, and the second is with, oh, I mean 10 minus 2R, okay? Yeah, just theta R equals 10 minus 2R. And next, according to the second equation, that half theta R squared 6.25 equals 6.25, and multiply by 2, and it is theta R squared equals 12.5. And the next step, divided by R, theta R equals 12.5. 5 over r. Now, this theta r equals 10 minus 2r. Theta r equals 12.5 over r. Theta r equals theta r. It means 10 minus 2r equals 12.5 over r. And then by minus 2r. Minus 2r becomes minus 20r plus 4r squared equals 25. Okay, minus 25. Sorry. So it becomes 4r squared minus 20r plus 25 equals 0. So it's one. Proof. Okay. Next, we're going to find r and theta. That's question B. Through this equation, that 10 minus 2r equals 12.5 over r, and we have this equation. Through this equation, simplify for 0, factorize 2r, 2r, and minus 5, minus 5. So 2r minus 5 for 0, so 5, oh sorry, r equals 5 half. R equals 5 half. Now, we are going to using this equation. Pi r equals 10 minus 2r. So r equals theta, sorry, not pi, this theta r. Theta r equals 10 minus 2r. Theta equals 10 minus 2r over r. So theta or angle equals 10 minus 2 times 5 over 2 over 5 over 2. And it is 10 minus 5 over 5 half. 5 over 5 half. 5 times 2 over 5. It is 2. So theta equals 2. And then r equals 5 half. Number 4, consider the function f(x) equals cosine x and gx equals sine 2x, where x interval 0 to pi. The graph of function f, intersects the graph of function g at the point A, this point. The point B, this point, but this point is theta pi over 2, comma 0. This is pi over 2. And the point C are shown on the following diagram. This is the point C, coordinate point C. Coordinate point A, coordinate point B, coordinate point C. So there are 3 intercept points. A, find the x coordinate point A. So we are going to find this x. Okay, how much this? Find x coordinate of point A and the x coordinate of point C. This coordinate, it means, right. To find that coordinate point, I'm going to writing here that fx equals gx. Okay, because they have coordinate point. It means uh, sine 2x equals cosine x. According to identity trigonometry, that sine 2x equals to sine x, cosine x equals cosine x. So divide it, becomes 2 sine x equals 1. Sine x equals half. And then x equals arc sine half. Arc sine half between 0 and pi. X equals pi over 6 and 5 pi over 6. So this is pi over 6. This one pi half, and this one pi over 6, 5 over 6 pi. Okay, so question A done. The shaded region R is enclosed by the graph of F and the graph of G between the points B and C, between B and C. Find the area of R. So our area we are going to using we are going to calculate by integral through integral pi half and pi over 6 half. Why pi half? 2 pi over 6 half, because uh, the shaded region between pi over 2, pi over half, and pi over 6, uh, 5 over 6 pi. And the function is cosine. Okay, cosine x minus sine 2x dx. Okay, because this is cosine x graph, and this graph is sine 2x. Okay, let's calculate it. So it's going to be integral by half to 5 over 6 pi. And the integral of this expression is sine x. Sine x plus minus plus half cosine 2x. And it is uh, sine 5 pi over 6 plus half cosine 2. over 6, pi over 6 minus sine this one pi half plus half cosine 2 multiply pi half. And it is sine 5 over 6 pi plus half cosine 5 third pi minus sine half pi minus half cosine pi. And if you calculate it, the result will be 1 over 4. That's the area of uh, this shaded region. Number 5, consider a geometric sequence with first term 1. 1 is the first term and common ratio equals 10. So 1, A is 1 or U first equals 1. U first equals A equals 1. And the common ratio R equals 10. Find out. So Sn is the sum of the first n terms of the sequence. Find an expression for Sn in the form a power n minus 1 over b, where a and b, okay. Right. So Sn, here. According to the formula of a geometric sequence, Sn equals a multiply r power n minus 1 over r minus 1 if ratio greater than 0. Okay. So it is a multiply r equals 10. So 10 power n minus 1 over 10 minus 1. So Sn, a equals 1. So it is 1 multiply 10 power n minus 1 over 9. So Sn equals 10 power n minus 1 over 9. So A equals 10 and B equals 9 according to this form. Hence, show that S1 plus S2 plus S3 plus so on till Sn equals 10 multiply 10 power n minus 1 minus 9n over 81. Okay. B so S1 plus S2 plus S3 plus on Sn equals this one Sn 10 power n minus 1 over 9. And then I will start from 10 power 1. Begin from 10 power 1 plus 10 squared, 9 plus on until 10 power n minus 1 over 9. By the sigma method, I'm going to write it like this, from I equals 1 to n. So this form we can writing 10 power I minus 1 over 9. And it is 1 over 9 sigma I equals 1 to n of 10 power I minus 1. Okay. And it's going to be, I need more space. It's going to be sigma 1 over 9 sigma I equals 1 to n 10 power I minus sigma I equals 1 to n of 1. And it is 1 over 9. Okay, this sigma equals 10 multiply 10 power n minus 1 over 9 minus this sigma equals n. And it becomes 1 over 9, 10 multiply 10 power n minus 1 over 9 minus 9n over 9. Or we can simplify, becomes 10 multiply 10 power n minus 1 minus 9n over 9. And it becomes 9 times 9. So it is 10 times 10 power n minus 1 minus 9n over 9 times 9, 81. So as n equals 10 times 10 power n minus 1 minus 9n over 81, like this one, like this statement. Six, the function f is defined as fx equals square root x sine x squared, where x interval from 0 to square root pi. Consider the shaded region R enclosed by the graph of f. The x-axis and the line x equals square root pi over 2, as shown in the following diagram. The shaded region R is rotated by 2 pi radians about the x-axis to form a solid. Okay, so it's rotated on the x-axis. Show that the volume of the solid is pi times 2 minus square root 2 over 4. Okay, if it's rotated on x-axis, so volume equals pi times integral 0 to square root, yeah, this one square root pi half. Okay, from this region from 0 to square root pi over 2. And the function fx squared dx, okay, because rotated on x-axis. So it's going to be pi 0 to square root pi half uh, root x sine x sine x sine x x sine x squared squared dx. I'm going to check the function. Okay, it's correct. And next it becomes pi integral 0 to the root pi half. And it becomes x sine x squared dx. I'm going to find the integral of x sine squared x. Integral, I'll be using the different color. Integral x sine x squared dx equals integral sine x squared x dx. U equals x squared. So it means du equals to x dx, or half du equals x dx. So this integral we can writing sine u x dx equals half du, and it becomes half times minus cosine u plus c, or minus half cosine u plus c. Okay. And then for the next step of this volume, this volume becomes pi 0 to square root pi half. So this integral equals minus half cosine u, or minus half cosine cosine x squared. Minus half cosine x squared. It is minus half cosine x squared. All right. And it's going to be minus half pi integral 0 to square root pi half cosine x squared. After that, substitute square root pi over 2 and 0 into this expression. Becomes minus half pi cosine square root pi half square minus cosine 0, 0 square minus half pi cosine quarter pi minus cosine 0 minus half pi cosine quarter pi equals half square root 2. Cosine 0 equals 1. Multiply. If multiply becomes minus quarter square root 2 pi minus or becomes plus because minus multiply minus becomes plus. Yeah. Or it is based on this information that 1 pi multiply 2, okay, factorize pi multiply by 2, okay, minus square root 2 over 4. Number 7, using mathematical induction and the definition of combination, this combinations, the combination n r equals this n factorial over r factorial multiply n minus r factorial. Prove that this we are going to prove. Sigma r equals 1 to n of these combinations are 1. We're going to prove that the sigma equals this combination n plus 1 and 2. For all n is element of integer positive. Okay. There are 3 steps. Okay, 3 steps to prove this proportion. The first step when n equals 1. Okay. When n equals 1, this part, okay, sigma I equals 1 to n of this combination, 1, okay. So it becomes, this is 1, okay. I'm going to write it here. So to find these combinations, 1 factorial over 1 factorial, 1 minus 1 factorial, and it is 1. Okay. And next, we are going to prove that this expression equals 1 also. The combination n plus 1, it means 1 plus 1, 2. 2 is going to be 2 factorials over 2 factorials, 2 minus 1 factorials. It is 1 also. Right, so when n equals 1, this proportion, is true for n equals 1. So this proportion is true for n equals 1. Next, the second is we have to assume that this proportion is true for n equals k. For n equals k. Let's clean this one first, and then for n equals k, we have to assume that okay, this proportions r equals 1, sigma r from r equals 1 to n of this combination, it equals n plus 1, combination n plus 1 and 2, and then it is true for okay, this condition r equals 1, r equals 1 to k because n equals k. So r equals 1 to k. It becomes k, combination k plus 1, 2. Okay. So we have to assume that this proportion is true. And the next step, the third step, this is true, this proportion. The second proportion and the second proportion, and now this, the third step. The third step, we have to assume that n equals k plus 1. We have to prove that if n equals k plus 1, the proportion is correct, right? So it means if n equals k plus 1, sigma r equals 1 to k plus 1 of this combination, it will be, I'm going to separate, okay, because this is k plus 1 becomes combinations are 1 plus the sigma plus no need to sigma, I mean combination k plus 1 of 1. So according to this equation, that this sigma equals this combination k plus 1 and 2. So this sigma becomes combination k plus 1, 2, okay, for this part. And now we are going to writing this one, k plus 1 and 1. After that, in factorial, this part becomes k plus 1 factorials over 2 multiply k minus 1 factorials, okay, plus k plus 1 factorials over k factorials, okay, this part. And next, it becomes k times k plus 1 factorials over 2k factorials plus 2k plus 1 factorials over 2k factorials. I recall that this according to factorials rules. Yeah. So it becomes this k. Uh, they have the same denominator. This denominator is 2k factorials. This denominator is k factorial. So from this fraction, yeah, we have to multiply 2 and 2 because we will set becomes the same factorials. So it's going to be k plus 1 factorials plus 2 k plus 1 factorials over 2k factorials. Look that this is k plus 1, this is k plus 1. So it becomes k plus 2 because this is k plus 2, k plus 1. And oh yeah, factorials over 2 factorials, k factorials. 2 equals 2 factorials because 2 factorials is 2 times 1. So it's going to be k plus 2 factorials over 2 factorials, k factorials. K plus 2 factorials is k plus 2 times k plus 1. Okay. And then the next is k plus 2 factorials over 2 factorials times k plus 2 minus 2. Okay. So it becomes factorials here becomes combination k plus 2 this one k plus 2 and then 2. So this one and this one. Okay. So prove that preposition the proposition okay, the proposition true for n equals 1 as well n equals k and then n equals k plus 1. Number 8. A. Find the first two non-zero terms in the Maclaurin series of the first sine x squared and the second sine squared of x squared. B. Hence or otherwise find the first two non-zero terms in the Maclaurin series of 4x sine x squared cosine x squared. So we're going to solving one by one. Firstly, sine x, the Maclaurin series of sine x squared, then the secondly, sine squared of x squared, and the third, we're going to find the first two non-zero terms in the Maclaurin series of this expression. Okay. Now the question is find the first two non-zero terms in the Maclaurin series of sine x squared. So first we have to find the series of sine x, and after that we are going to figure out Maclaurin series for sine x squared. So the first step, we need to find function x first, or function of sine x, and then if x equals 0, it's going to be sine 0 or 0. And then the first derivative of sine x is cosine x. Okay, so if x equals 0, becomes cosine 0, 0. Next, the second derivative of sine x, it is minus sine x, or derivative of cosine x. And then if x equals 0, will be minus sine 0 equals 0. Sorry, this is 1. Cosine 0 equals 1. Okay, this one. Then the third derivative, or derivative of minus sine x, equals minus cosine x. And if x equals 0, will be minus cosine 0, or minus 1. And the next step, we're going to apply these results into the Maclaurin series, like this. So fx, or sin x, will be f0 plus x over 1 factorial of f0 of derivative of uh, the first derivative, plus x plus 0, plus x squared over 2 factorials, and the second derivative is 0, the x is 0, then x cubed over 3 factorials of the third derivative, but x equals 0, so on. So it means sine x, because fx equals sine x. Sine x will be f0 equals this one, 0, 0, plus 1 times x over 1 factorial of x, 1x. This is 0. Why? Because the second derivative equals 0. That's 0, plus, and this one is the third derivative. Sorry, this is the third derivative equals minus 1. So it will be minus 1 times x cubed over 3 factorials, so on. So this is the Maclaurin series, x minus x cubed over 3 factorials plus so on. This is the Maclaurin series for sine x. So what if sine x squared? For sine x squared, I'm going to replace its x, uh, its x on sine x. This is sine x, Maclaurin series of sine x. In the sine x squared into here, so replace x with x squared. Okay, so it becomes sine x squared. The Maclaurin series of sine x squared becomes x squared minus x squared cube over 3 factorials plus all. Okay. And then sine x squared equals x squared minus x power 6 over 3 factorials plus so on. So this is the Maclaurin series for sine x squared. Now, find the first two non-zero terms in the Maclaurin series of sine squared x squared. We're going to figure out the solutions of these problems of first two non-zero, first two non-zero terms. Okay. I have explained about the Maclaurin series of sine x squared. Okay, and the Maclaurin series for sine x squared is x squared minus 6 x power 6 over 3 factorials and so on. These are the two non-zero terms in the Maclaurin series of sine x squared. So how about if sine squared x squared? Okay, to find these solutions, we need to, I'm going to write becomes like this, sine x squared squared. So sine squared x squared, we can writing becomes sine x squared squared like this. And then for the Maclaurin series of this expression, we can uh, find through this Maclaurin series sine x squared this plus on squared like this. Okay, so it means it becomes x squared minus x power 6 over 3 factorials multiply x squared minus x power 6 over 3 factorials. Recall that we just find the first two non-zero terms. So let's recalculate. X squared multiply x squared equals x power 4. Okay? And then x squared multiply this second term will be minus x power 8, okay, over 3 factorial. And then this one, the second term, this will be times x squared, x power 8 over 3 factorials. We just find this, the two non-zero terms. So this enough plus so on. So it becomes x power 4 minus 2x power 8 over 3 factorials. So this is the Maclaurin series of sine squared x squared. Okay. We're going to discuss how we find the first two non-zero terms in the Maclaurin series of for x sine x squared cosine x squared. I have explained on my previous explanations regarding how we find Maclaurin series of sine x squared. Okay, Maclaurin series of sine x squared is x squared minus x over 6 over 3 factorial. Uh, this is just two non-zero terms. So how about if cosine squared, cosine x squared, the Maclaurin series of cosine x squared, right? Uh, for cosine x squared, I will discuss first if fx cosine x means f0 equals 1 because cos 0 equals 1. So we should discuss this first, cosine x first, and after that, apply into x squared. And the first derivative of cosine x is minus sine x. And if x equals 0, it is 0. And the second derivative of cosine x is minus cosine x. And if x equals 0, it is minus 1. Okay. Now, so how about if the Maclaurin series of cosine x? The Maclaurin series will be 1 plus 0, okay, 0 times x over 1 factorial. And then plus minus 1 this times x squared over 2 factorials. Already 2 non-zero. So it is 1 minus x squared over 2 factorials. It means cosine x, Maclaurin of cosine x, Maclaurin series of cosine x, it means 1 minus x squared over 2 factorials, so on. This is Maclaurin series of cosine x. So how about Maclaurin series for x squared? Okay, with the same method when I explain you regarding how we figure out Maclaurin series of sine x squared, just apply x squared into this Maclaurin series cosine x. So it means for cosine x squared, the Maclaurin series will be 1 minus x squared squared. This one, this fraction over 2 factorials plus on. And it will be 1 minus x power 4 over 2 factorials plus so on. Sine x squared already, this one, cosine x squared already, this one, this cosine x squared, Maclaurin series, right? Now, through the information about uh, Maclaurin series of sine x squared and cosine x squared, we can determine Maclaurin series of 4x sine x squared cosine x squared will be 4x multiply this series x squared minus x over 6 over 3 factorials. Then multiply this series 1 minus x over 4 over 2 factorials. Okay. Sorry, I forgot to maybe this is not only two terms. Okay, this is class on and 1 minus the series of 4, 2 factorials, so on. And if you calculate it, if you multiply 1 by 1, you can find the Maclaurin series of fx sine x squared cosine x squared is 4 for x cubed. I have calculated it minus 8x power 7 over 3, so on. Or you can writing 4x cubed minus 8 over 3 x power 7 plus so on. So this is the Maclaurin series of 4x sine x squared cosine x squared. The first two non-zero terms. One, this is the first non-zero term. This is the second non-zero terms. Number 9, the graph of y equals f modulus x for interval x minus 6 to 6 is shown in the following diagram. This is diagram of f modulus x. Y equals f modulus x. This is the diagram. Okay. On the following axis, sketch the graph of y modulus fx. Okay. The difference between this function and the second function modulus f modulus x, on this function there is no value for y is negative, so there is negative value for y. It means all y values are positive. If all y values are positive, it means this line will be moved to here as well, this line. So it will be like this. Okay. So as well, like this. Like this. And it will be like this. Why? Because if modulus, it means there is no values for negative. Okay, I will click this. Okay, this is the graph for y equals modulus fx. Modulus f, modulus x. The graph is this one. Okay, this is the graph. Okay. Next. It is given that f is an odd function on the following axis. Sketch the graph of y equals fx with the same integral. Just now we have sketched y equals modulus f fx. Okay, from uh, the first the first diagram, the first graph, y equals f modulus x. Okay, now we're going to sketch this graph, an odd function graph. For odd function graph, symmetry, it has symmetry and the symmetry about the origin here. Okay, if I will sketch the graph, would be like this. At the right side, the graph will be like this. Now at the right side, okay. And at the left, I'm going to use the different color. At the left becomes like this, but uh, it is one graph. Okay, yeah. And this is the graph of an odd function. Graph of y equals fx. Next, it is also given that integral 0 to 4 of f modulus x dx is equals 1.6. It means integral 0 to 4 f modulus x dx. It is integral 0 to 4, and if the integral of this expression is f, so becomes f4 minus f0. Okay, and according to this statement that it is 1.6, it means f modulus 4 equals 1.6. So the implication is if f minus 4, it is 1.6, because modulus 4 is 1.6, and if f4, it is 1.6. All right. I'll write down the value of firstly this one. So this integral we can writing as integral wait minus 4 to 0, and the integral fx. Okay, and I'm going to change different color. Okay, so it is f 0 minus f minus 4. F0 equals 0 and minus 4. F minus 4 is 1.6. So it is minus 1.6. And the second, this integral. And for this integral, I will expand like this. Minus 4 with better if 0 to 0 to minus 0 to 4, and after that minus 4 to minus 4 to 0, and then 0 to 4. Okay, so it becomes wait, f minus 0 to 4 becomes f this expression dx plus integral 0 to 4, this expression. Yes. Okay. So it becomes, I'm going to write in here, move here. This integral, integral 0 to 4, dx, okay, plus integral 0 to 4, this one, plus this one, integral minus 4 to 0, dx already, and this one minus 4 to 0, this expression. Okay. Recall that this integral is 1.6. Okay. And as well, this integral is 1.6. Dx and plus this minus 4 to 0 fx, sorry, which one? Okay, this is 0 to 4 f x is 1.6, this integral, and then minus 4. Oh, this one, this integral is what? This is minus 1.6. This integral minus 4, 0, dx plus this. This integral is this one minus 1.6. So it means it is minus. And if this integral fx becomes f4 minus f0, while this integral f 0, okay, minus f um, sorry, modulus 4. Okay, so it becomes, this is 0. Okay, this is 1.6. As well, this is minus because odd fraction. So it becomes 1.6 plus 1.6. It is 3.2. Number 10. Consider the function of x equals 4x plus 2 over x minus 2, which x unequal to. Sketch the graph of y equals fx. On your sketch, indicate that the values of any axis intercepts and label any asymptotes with their equations. Okay, so this function is a rational function. Okay, so how to sketch these rational functions? We need to determine the intercept, intercept with axis, and then we need to determine asymptote equations. Right. I'm going uh, to sketch in this space A. Firstly, uh, I will find the vertically asymptote. Asymptote. Okay. How to find it? Based on the denominator, and the denominator should be 0. The function is y equals 4x plus 2 over x minus 2. This is the denominator, so denominator should be equal 0. X minus 2 equals 0. So x equals 2. So x equals 2 is the equation for the vertically asymptote. And the next step, horizontally asymptote. Okay. For horizontally asymptote, uh, just comparing leading terms. The function y equals 4x plus 2 over x minus 2. Comparing the leading terms. So in this function, comparing between 4x and 1x. So y equals 4x over 1x equals 4. So the equation for horizontally asymptote is y equals 4. So these are the vertically asymptote and horizontally asymptote. And the next step is intercept point. We need to determine intercept point. Right. Intercept points when y equals 0. Y equals 0, it means intercept point on x-axis. This intercept point on x-axis. intercept point on x-axis. Okay, y equals 0. If y equals 0, it means this function will be 4x plus 2 over x minus 2 equals 0. It becomes 4x plus 2 equals 0 because x minus 2 multiplied by 0. So fx equals minus 2 and x equals minus half. So the intercept point x comma y minus half comma 0. Next, intercept point on y-axis. On y-axis, when x equals 0. If x equals 0, this function will be y equals 4 times 0 plus 2 over 0 minus 2. It is minus 1. Okay, so intercept point on y-axis is 0, comma, minus 1. Let me sketch this graph. Okay. Okay. Okay, this graph here. This is the y-axis, and this is the x-axis. Okay. We need to sketch first asymptotes. X equals to here. So x equals to, we need to create the straight line. Okay, this is x equals 2. And then y equals 4. Y equals 4 around here. Different color. Okay. This is the horizontally asymptote. Y equals 4. So this asymptote, this straight line is asymptote x equals 2, and this straight line, the horizontally straight line, is asymptote y equals 4. Now, we need to find this intercept point, okay, on x-axis. If this is 1, this minus half, comma 0, this intercept point. And then 0, comma minus 1, 0, comma minus 1 on here. Okay. 0, comma minus 1. And then we are going to sketch. I'm going to using this color. Okay. This is the graph. Okay, through this coordinate point. And this one. Okay. Okay. So this is the graph of y equals for x plus 2 over x minus 2. That is A. Now write down the range of function f. The range of function f we can determine range of function b. Okay, range of f we can determine through this way. Y is function first. Y equals 4x plus 2 over x minus 2. And calculate y, multiply with the denominator becomes xy minus 2y equals 4x plus 2. And after that, 4x moves to here, and minus 2y moves here to the right. Becomes by factorization x 4 2y plus 2. So x equals to y plus 2 over y minus 4. So look the denominator. Okay, denominator of this function. So range of function f should be y minus 4, y minus 4 unequal 0. So the results of y minus 4 not 0. Yeah. So it means y unequal 4. Okay. So the value of y cannot 4 because if 4, it means not include of the range of this function. This C. Consider the function gx equals x squared plus bx plus c, quadratic equation, quadratic function. The graph of g has an axis of symmetry at x equals 2. So the symmetry x equals 2. The two roots of gx equals 0 are minus half and p. Roots of this function are minus half and p, where p is element of the rational number, the the real number. Now show that p equals 9 half. Okay. I'm going to sketch this function, the quadratic function. See the quadratic function according to the information that the quadratic function has symmetry 2. Okay. And it has root minus half and another root here on x-axis. So the graph will be like this. The graph of this quadratic function. Okay. Now we're going to find this is p, because the roots of this function are minus half and p. Okay, so it means we can determine P through, wait, through measuring that this is X equals 2, this is 2, measuring the distance from minus half to 2. The distance from minus half to 2 is 2.5 or 2 half. So it means the distance from 2 to P is 2.5 as well. So uh, this intercept point or P is 2 plus 2.5, 4.5 or 4 half. So P equals 4 half or 9 half. This. Find the value of B and the value of C. We need to find this value B and C. Okay. Right. So the two roots of this quadratic function is minus half, okay, and 9 over 2. It means x plus half, x minus 9 half equals 0. Okay, if equation about this function, sorry, equals fx. Okay, so fx, x squared, because uh, multiply, and then minus 9 half x plus half x minus 9 over 4 becomes x squared minus 8 half x minus 9 over 4. So fx, x squared minus 4x minus 9 over 4. So a equals 1. This one a. This is a. B equals minus 4. And C equals minus 9 over 4. Done. Next, define the value already. Find the y coordinate of the vertex of the graph of y equals gx, right? To find the vertex, okay, to find the vertex that, so wait, E, okay, wait, I'm gonna change color. Yeah, the function y equals x squared minus 4x minus 9 over 4, okay? Recall that the symmetry is x equals 2. Substitute this value of symmetry into this function. And comes y 2 squared minus 4 times 2 minus 9 over 4. 4 minus 8 minus 9 over 4. So it becomes minus 4 minus 4 quarter, and it is minus, if you calculate, will be, wait, 8. 1, sorry, 4, and then, oh, sorry, this is actually 2, not 4. Okay, 2, so becomes 6 or 25. Yeah. This the value of y, so minus here. So the vertex, I'm going to add here, vertex is 2 from this one, the symmetry, and the value of y, 25 over 4 minus here. What else? Vertex, okay. Find the product of the solutions of the equation of the product. Find the product of the solutions of the equations fx equals gx. Okay, fx equals gx. And the product formula is d over minus d over a. But we have to find the new function is fx. Okay, fx equals dx. So it means fx is 4x plus 2 over x minus 2. It means 4x plus 2 over x minus 2 equals dx, x plus half, x minus 9 over 4. So we're going to calculate becomes fx plus 2. Fx plus 2 is x minus 2 times 1x squared minus 9 over 4x plus half x minus 9 over 8. That one. Okay. 9 over, wait, not 9 over 2, but 9 over, not 9 over 4, but 9 over 2 here. Sorry. It's supposed to be 2. 2, 2. Okay. So it's going to be x minus 2, x squared, minus 4x, minus 9 over 4. Right. 9 over 2. Or, wait, I'm going to check once more. 9 over 4, sorry. 9 over 2, yeah, half times, possibly this is 2, this is 2, and this is 4. Right? Yeah, already. Okay, so it is 2 and is 4, right? Correct. So fx plus 2, if you calculate, it's gonna be with x cubed. Okay, wait, I will calculate, yeah, x cubed, then minus 4x squared, minus 9 over 4x, minus 2x squared, plus 8x, plus 18 over 4. So becomes x cubed minus 6x squared, and then plus, okay, 8 minus this is 2 1 over 4, it means if 2 x minus 2, it means 5 x 3 quarter x plus 18 over 4. Next, I need more space. So if you continue to expand this, you can find an equation like this, 4x cubed, okay, 4x cubed minus 24 x squared x minus 16x plus 10 equals 0. Yeah, let's check. Okay, good. Yeah, you're gonna find this because if you multiply by 4, this multiply by 4. So finally, you can find this equation. So if we identify this, is becomes the product, the product of the roots. Okay. The product of the roots with I have this is still x, so it becomes the product of the roots of 4x cubed minus 24x squared. 23 minus 16 is 7 plus 10 equals 0. The product of the roots of this equation is minus d over a. This is the formula if the equation is the cubic equation, the cube equation, I mean, with the higher power is 3. So if you identify this equation, a equals 4, b minus 24, c 7, d 10. So the product of the roots minus d over a, it means minus 10 over 4, because a equals 4. Simplify becomes minus 5 half. This is the product of the roots. Number 11. Consider the polynomial px equals 3x cubed plus 5x squared plus x minus 1. Show that x plus 1 is a factor of the x. To show that x plus 1 is a factor of px, so we have to substitute x equals minus 1 into px. Okay, so I need more space to downwards. This one. Okay, px equals 3x cubed plus 5x squared plus x minus 1. So we're going to substitute x minus 1 into px because we will figure out that x plus 1 is a factor of this function px. 3 minus 1 cubed plus 5 minus 1 squared, 1 minus 1, and if you calculate, it is 0. Okay, if 0, it means x plus 1 is a factor of px. Okay. And b, hence, express px as a product of three linear factors. Okay, so we are going to find three linear factors of px. B. One factor of px is x plus 1. So I will, using this method, Horner method, 3, 5, 1, minus 1. Divided by minus 1, x equals minus 1, 3, minus 3, 2, minus 2, minus 1, 1, 0. And I will continue to divide by minus 1 once more. Minus 3, minus 1, 1, and the remainder equals 0. So it means px, px equals 3x cubed plus 5x squared plus x minus 1 has three linear factors, and the three linear factors are x plus 1, x plus 1, and 3x minus 1. Yeah, it's x plus 1, x plus 1, and 3x minus 1. Next. Now consider the polynomial qx equals x plus 1 times 2x plus 1. Express 1 over qx in the form of a over x plus 1 plus b over 2x plus 1. Okay, where a and b element of integer. Okay. So C 1 over, yeah, qx equals, we can check, qx x plus 1 to x plus 1, okay? X plus 1 to x plus 1. So 1 over qx. It means 1 over x plus 1 to x plus 1. Okay. Equals a plus x plus 1 plus b to x plus 1. And it becomes a times 2x plus 1 plus b times x plus 1 over x plus 1 times 2x plus 1 is 1 over x plus 1 to x plus 1. And it becomes a times 2x plus 1 plus b times x plus 1 equals 1, this. And after that, multiply 2ax plus A plus bx plus b 1. And factorize 2a plus b x plus a plus b equals 1. So there are two equations. 2a plus b equals 0 and a plus b equals 1. A equals minus 1. A equals minus 1. It means a plus b equals 1. So a equals minus 1, it means minus 1 plus b equals 1. So b equals 2. So it means 1 over qx, okay, 1 over x plus 1 to x plus 1 equals 1 over x. Okay, a equals minus 1, so it will be minus 1 over x plus 1, and b equals 2. So plus 2 over 2x plus 1. This. Next. D, hence, or otherwise, show that 1 over x plus 1 qx equals 4 over 2x plus 1 minus 2 over x plus 1 minus 1 over x plus 1 squared. Okay. Next for option D. Option D, 1 over, okay, 1 over uh, x plus 1 and qx x plus 1 to x plus 1. It is 1 over x plus 1 times 1 over x plus 1 times 1 over 2x plus 1, like this. About this part, this term, I will using a previous strategy A and B. A plus B becomes like this. Better if I use the different color. Okay. So 1 over plus 1 times 2x plus 1, this term, equivalent with A over x plus 1 plus B over 2x plus 1 becomes A 2x plus 1 plus B x plus 1 over x plus 1 to x plus 1 becomes 2ax plus a plus bx plus b over x plus 1 to x plus 1. It becomes 2a plus b x plus a plus b over x plus 1 to x plus 1. This is 1 over x plus 1 times 2x plus 1. So through this equation, uh, we can writing that a plus b equals 0 because there's no x here. There is no variable x here, only 1. And a plus b equals 1. So it means to a minus a minus 1. A plus b equals 1. So minus 1 plus b equals 1. So b equals 2. So 1 over this term, 1 over x plus 1 times 2x plus 1 equals minus 1 over x plus 1 plus 2 over 2x plus 1. Right. So this term, I will change, I will writing with this part, with this term, right? As we continue to expand this. So 1 over with 1 over x plus 1, x plus 1 to x plus 1. It is equals 1 over x plus 1 times this part minus 1 over x plus 1 plus 2 over 2x plus 1. Okay? So it's going to be, now we're going to multiply times becomes minus 1 over x plus 1 squared. Okay? And then this term times this term becomes plus 2 over x plus 1 to x plus 1. And the next step, we'll continue to expand. It's going to be minus 1 over x plus 1 squared plus 2 in brackets. 1 over x plus 1 to x plus 1. And I will continue, it becomes minus 1 over x plus 1 squared plus 2 in brackets. This term equals, so now we already got 1 over x plus 1 to x plus 1 is same with this one. Okay, so we already expand just now here. So I'm going to change this part with this part. So it's going to be 2 times minus x plus 1 plus 2 over 2x plus 1, like this. And it becomes minus 1 over x plus 1 squared, okay, minus 2 over x plus 1, and then minus, wait, okay, sorry, minus, okay, becomes 4, sorry, okay, 4 over 2x plus 1. So it becomes 4 over 2x plus 1 minus 2 over x plus 1 minus 1 over x plus 1 squared. That is D. Next, D already. Hence, find integral 1 over x squared, x plus 1 squared, okay, times 2x plus 1. E integral 1 over x plus 1 squared to x plus 1 dx. Okay, recall that this term same with this term. So I can writing like this, integral 4 over 2x plus 1 minus 2 over x plus 1 minus 1 over x plus 1 squared dx. So I will separate 4, 1 over 2x plus 1 dx minus 2, 1 over x plus 1 dx minus integral 1 over x plus 1 squared dx. And it becomes 4. The integral of this expression is half ln 2x plus 1 minus 2 ln x plus 1 minus 1 over x plus 1 plus c. Becomes 2 ln 2x plus 1 minus 2 ln x plus 1. So different. This is 2 and ln 2x plus 1. This is 2 ln x plus 1 plus 1 over x plus 1 plus c. So this the integral of 1 over x plus 1 squared to x plus 1 dx. Next, f. Find limit x approach minus 1 fx, limit x approach indefinite fx. Okay, this fx dx over x plus 1 qx. f px equals 3x cubed plus 5x squared plus x minus 1. And we already have the roots, x plus 1 squared, 3x minus 1. We already get the roots and we can factorize like this, the px. So according to the statement that fx equals px over x plus 1 qx, means x plus 1 to x plus 1. And px is x plus 1 squared, 3x minus 1 over x plus 1 squared to x plus 1. Like it becomes 3x minus 1 over 2x plus 1. So fx equals this. Next, limit is the limit x approach to minus 1, 3x minus 1 over 2x plus 1. It is 3 times minus 1 over 2 minus 1. And if you calculate, becomes minus 4 over minus 1. It is 4. And the second, limit x goes to indefinite, 3x plus 1 over 2x plus 1. And if you divide it by x, 2x over x plus 1 over x becomes 3 minus 0, 2 minus 0, it is 3 half this. Consider P equals A plus BI cubed, where AB element of real numbers. In terms of A and B, find the real part of phi, the imaginary part of phi. Okay. A, I'm going to look, yeah, A plus, A plus BI cube. Okay. So it becomes A plus BI squared, A plus BI. Multiply it. If you multiply, it becomes A squared. We have to expand this part first. After that, multiply. And it's going to be 2ABI minus, yeah, or minus B, because I squared equals minus A plus BI. And if we calculate, it's going to be A cube, 3A squared B, 3A squared BI, I mean, because A squared times 1 and plus minus 1, 3AB squared minus B cube I. And it's going to be A cube minus 3ab squared plus 3a squared bi minus b cubed I. And I'm going to factorize it. Okay. 3a squared b minus b cubed I. So the real parts are a cubed minus 3a squared b, while the imaginary parts are this part is imaginary parts. So 3a squared b minus b cubed. So what? Next, b. Hence, or otherwise, show that 1 plus 1 plus square root 3 I cube equals minus 8. 1 plus square root 3i. Okay. Okay, I'm gonna using the different color. Okay, part B. 1 plus square root 3i cube. We have to expand this, becomes 1 plus square root 3i squared times 1 plus square root 3i. Okay, and it becomes 1 plus 2 square root 3i, and then minus, because I squared equals minus 1, square root 3 squared is 3, and plus square root 3i. Then multiply. Oh wait, 1 minus 3 first. So it will be minus 2 plus 2 square root 3i times 1 plus 3i, and it becomes multiply minus 2 minus 2 square root 3i, then plus 2 square root 3i plus 2 times minus 3, 0. So it is minus 2 minus 6. It is minus 8. So B, this one, the solution, minus 8. Now C. The roots of the equation z cubed equals minus 8 are u, v, and w, where u equals 1 plus square root 3i, and v, element r, member of r. Write down v and w, giving your answer in Cartesian form. Okay. I'm gonna just becomes this. Okay. See, the cube equals 8. So equals minus 8, I mean. So it means z cube plus 8 equals 0. So the possibilities is z plus 2 times c squared minus 2z plus 4. If we multiply this term and this term, the result equals c cubed plus 8 equals 0. Okay, so it means c plus 2 equals 0, or c squared minus 2c plus 4 equals 0. That is c equals minus 2. And for this part, to find a c on this part, I'm going to using ABC formula of quadratic equation, which A equals 1, B equals 2, and B equals minus 2. Minus 2, C equals 4. Okay, so I'm going to move here, Z1 and 2. Minus 2, it means plus. So positive 2 plus minus 2 squared minus 4 times 8 times 4 over 2 times 1. It will be 2 plus minus square root 4 minus 16 over 2. So it will be 2 plus minus square root minus 12 over 2. So it's going to be 2 plus minus square root 12 times square root minus 1, but I'm going to writing I. Okay. So next, 2 plus minus 2 square root 3 I over 2. So it means z equals 2 divided by 2, 1 plus minus 2 divided by 2, 1, 3 I. Okay. So it means u equals 1 plus square root 3 I. Okay. And that v equals minus 2. Okay. And then w equals 1 minus 3i. Okay. That are u, c, and w. Find the area of the triangle u on an argon triagram u, c, and w are represented by the points u, c, and w respectively. Find the area of triangle u, c, and w. Okay, so I'm going to find the area of u, c, w. Okay, this, sorry, okay. So area of, I'm going to, I will sketch first the area on argon diagram like this. This is imaginary, and this is, okay, the real. Okay, imaginary and the real axis. Okay. So firstly we're gonna find minus 2 on real, minus 1, minus 2 around here, minus 2, and then 1 and plus square root 3. 1 on real here, and 1 here to here on imaginary axis. Okay, square root 3 around here, minus square root 3 around here. So this is 1 plus square root 3 I, and this coordinate point 1 minus square root 3 I. And I will create a triangle. Okay, after that we're gonna calculate the area of this triangle. Okay, so area, this is U, this is W, this is P. Okay, area UVW equals half times times base is the base is 2 square root 3. Okay, 1 to 1 plus 1 equals 2. 2 square root 3 times the height is 1, 2, 3 times 3. Okay, so it becomes, okay, 3 square root 3 square unit, this. Okay, what else? G already, find the area. Each of the points U, V, and W is rotated counterclockwise or anti-clockwise about 0, about 0 through an angle of pi over 4. This is 90 degrees, okay, but pi in pi term. To form three new points, ux and vx and wx. These points represent the complex number ux and vx and wx and respectively. Find ux and vx and wx, and giving your answer in the form in exponents, in exponential, according to Euler, where theta interval greater than minus pi, less than or equal pi, okay, not including minus pi, okay. Okay, next. That is E. U equals 1 plus square root 3 I. Okay, so it means R, we have to calculate R. R equals 1 squared plus square root 3 squared. It is square root 4 or 2. So, and then arc tangent square root 3 over 1. Square root 3 is pi third. So, I'm gonna move here. U equals 2 e to e pi third I. Okay. And then, according to this information, that rotated about 0 through an angle pi over 4. Okay. It means we have how to find UXN, the imagine of U. It means 2e pi third I be multiplied by e power pi over 4 I. Okay, and it is to e power 7 over 12I. That imagine of phi or u of u is or u accent. Now phi equals 2 minus 2, I mean. So r, it means square root minus 2 squared is 2. So arctangent 0 over 2 because imaginary number here is 0. So 0 over 2 equals 0. It is pi. Okay. So it means V equals 2e pi I. Okay. To find Vx, and it means 2e pi I times e power pi over 4I. And it is 2e power, if 1 plus 1 over 4, it means 5 over 4 pi I. But we have to find on third quadrant because the position of this angle is on third quadrant. So it means on third quadrant is 2e power minus 3 over 4 pi I. Okay. Next, W. W is, wait, if I'm not mistaken, if this plus is minus 1 minus square root 3. Okay. Or 3, so 3I. So R equals, wait, okay, R equals square root 1 squared plus minus square root 3 squared. It is square root 4, 2. So it means W is 2 2e power minus pi third. Okay, so minus pi third or 1 over 3 pi. Okay, and if W accent or the imagine of W is 2e power minus pi third. Sorry, arctangent first, arctangent. Arctangent minus square root 3 over 1, so minus square root 3. That is minus pi third. Okay. And then multiply e power I, it is 2e power minus, multiply, it becomes minus pi over 12 I. Yeah, that U, V, and W. What else? Now F. Given that Ux and Vx and Wx are the solutions of C cube plus C plus D, where C and D element of real numbers, find the value of C and the value of D. Okay, right. It means F U x n cube. Wait a second, wait. Okay, this one. Z cube. Okay, ux n cube. It will be 2e power 7 over 12 pi I cube. Okay, and so this number from this one, later on one, and after that this one. But if you will find through P, you can, or W, you can using that number. Next, it will be, if cube will be 8, e power 21 over 12 by I, or it will be 8 e power 7 over 4 by I. Okay, so sorry, ux and cube, I mean. Okay, x and cube. Uh, it becomes 7 over 4 at third quadrant. So it becomes 8 e power minus 1 over 4 pi, okay, at third quadrant, or comes 8 e minus pi over 4. So it means u x and cube would be 8 cosine minus pi over 4 plus I sine minus pi over 4. And it is 8 cosine minus pi over 4 is half root 2, and this one is minus half root 2 I brackets. And next, it is 8 times half for 2I. Okay, and I will convert it. Oh, this is C, this is D. Okay, C equals 4 square root 2, or 8 over 2 square root 2, or 8 over square root 2. So D equals minus 4 square root 2, or minus 8 over 2 square root 2, or minus 8 over square root 2. Next, G out. This one is given that U, V, W, Ux, and V, and W, X, and are all solutions of Z power N equals alpha for some alpha elements of C, this number where N element of N, this number, and this number. Okay. Find the smallest positive value of N. So G, I'm going to use in a different color. This one. Okay. Z equals R cosine theta plus I sine theta. So C power N, it means equals R power N times cosine N theta plus I sine N theta. Okay. Which is theta equals minus 3 pi over 4 uh, minus pi third minus pi over 12, then pi over 3, 7 over 12 pi, and pi itself. So this pi, this angle taken uh, phi, u, w, phi accent, u accent, and w accent. Now let's recheck one by one. We have to find a the result multiple of 2. I'm going to start if n equals 6. N equals 6. If n equals 6, so it's going to be 6 times 3 over 4 becomes minus 18 over 4 pi. Or it is minus 9 half pi. If 6 times this one is going to be minus 2. Okay, minus 2 pi. If 6 times this number, it's going to be minus 6 over 12 pi or minus half pi. Next, if 6 times this number, this angle becomes 6 over 3 pi or 2 pi. If 6 times 7 over 12 will be 42 over 12 pi. Or we can simplify become 7, 2 pi. If 6 times pi, it's going to be 6 pi. So look, that's the number, 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 that's fraction for that. This number are not multiply of 2 pi. So how about if n equals 6 plus 6, 12? Correct. Check if 12. If 12 times this number, I have calculated 8. If 12, it's going to be minus 9 pi, minus 4 pi, and then minus pi, and it's 7 pi, and 12 pi. No multiply of 2 pi. What if n equals 24? If n equals 24, 24 times this number, this angle is this r minus 18 pi, 8 pi minus 8 pi, and minus 2 pi, 8 pi, 14 pi, and 24 pi. Look that this angle are multiplied of 2, of 2 pi. So the conclusion is we can, for this part for G, that n equals 24. This. Okay, students, if you have any questions, you may send me your email. Thank you for joining with me in this lesson. Bye.